Yeah, now, so probability. So in this case, look at here. Let me start with the basic definition of probability. Okay, in any toss, in any event or anything. Okay, you can talk about probability of getting A. Am I right? Is that okay? So there may be different so there may be different possibilities of any. So there may be different outcomes, okay, of any what you call event, toss, or whatever you take, okay. So then among those outcome, A is one of the outcome, okay. So now what is the probability of getting A? How to define this one? Number of events favorable to A whole divided by total number of possible events. If you have any problem with probability, basic probability, you quickly go through some chapters of class 12th, okay. So that will give you much more hold, okay. A number of events favorable to A, total number of possible events, okay. Now again we shall go to tossing coin, okay. So probability of getting head is, okay, if you toss a coin, so then what is the number of events that is favorable to A? You can, there is one head, one possible tail, am I right? So that is again 1. Total number of possible, so total number of different events, actually you have to write total number of different possible event. Is that okay? So that's given by 2 here, isn't it? You can have head as well as so tail here, isn't it? So like that you can define. So like that you can define probability of being tail, isn't it? So number of event that is favorable to tail, that is 1. So total number of possible event, that is 2, head and tail. Is that okay? That's how we apply. So similarly, so in case of dice, okay, in case of dice, so there are 6 different possible events, isn't it? 6 different possible event, number 1 to 6, isn't it? So now, so probability of getting 1, that's equal to 1 by 6. So probability of getting 2, that's also equal to 1 by 6. Am I right? You have only 1 over there. So like that you can write in case of dice, okay. Now look at here. How did you ensure this one, okay? This probability is half and half. Look at here. So this definition, okay, this definition is backed by one more thing, that is all events are equally priori. If all events are equally probable, then only you can write like this. If probability of head is equal to probability of tail, then only you can write half and half, isn't it? Are you getting my point? So this definition is backed by one more kind of theorem or instruction. So that is if all events are equally priori, if all events have equal probability of happening, if none of the events are favored, if none of the events are more favored than other, so then only you can have this definition of probability, okay. So then you can define it like this. I hope you can do this one yourself. So now next part is, okay, you say probability of getting head is equal to half, isn't it? We are going to study this probability theory again in the beginning of statistical physics, okay. You don't have to worry much now, okay. Now look at here. You said probability of being head is equal to half, isn't it? Now again, if you toss coin twice, okay, if you toss coin twice, okay, so then suppose both of the time you got head. You said probability of being head is equal to half, tail is equal to half, am I right? You toss coin twice, unfortunately both of the time you got head. Then what I am going to say is you are lying. Probability of being head is 100%. Probability of being tail is 0%. Isn't it? I am going to say like that, isn't it? So then how do you convince me that probability of being head is equal to half, tail is equal to half? Quickly tell me. Yeah, you should increase number of trials, isn't it? You should increase number of trials to more and more what you call, so trials. When you do more and more, now look at here, probability of being head is equal to half means 1 with 1, look at here, any probability definition, okay, you should do some statistical interpretation. Are you getting my point? Statistical interpretation means you should take large number of trials, you should take the outcome and you should measure the outcome, then you have to take the ratio. Is that okay? Any probability idea, not only here, again in case of quantum mechanics also. I told infinitely many identically prepared systems, right? Here we can toss the same coin because each toss is not disturbing the shape of coin, okay? Each measurement is not disturbing the shape of the pen. Now look at here. Any probability definition, again, if you want to implement that one, or if you want to show that one, you should go for statistical interpretation. That means you need to take large number of trials to show that one. Is that okay? So this probability of being head is equal to half means by one toss you can't show this one at all. By even two toss you can't show that one. Is that okay? You should take millions of trials. So then the ratio of being head divided by total number of trials, that will be nearly equal to half. Okay. So let me give you one small mathematics here. Okay. Suppose if you have done 10 trials. Okay. Among 10 trials, suppose 4 head, 6 tail. So 10 trials. Okay. Okay, you got 4 head, 6 tail. So then what is the ratio of a head that is 4 by 10? Am I right? What is this value quickly? 0.4, isn't it? I'm taking unequal because you, again, if you toss coin twice means, again, one time you will get head, next time you will definitely get tail. No, that's not the meaning of. So again, this will not show off itself like that. Are you getting my point? Probability of head is equal to half, tail equal to half means if you do 2 trials, first one will be, again, it is 50-50 probability, isn't it? First trial give you head, second trial definitely give you tail. No, not like that. If you do 10 trials, okay, if you do 10 trial, 5 trial will give you head, 5 trial will give you tail. It's not like that. Okay, I'll take some imbalance between them. Okay, so now look at here, this ratio is 0.4, isn't it? I'll take 100 trials. Suppose among 100 trial, 49 head and 51 tail. Let me take like that. So then the ratio of head divided by total number of trial, that is equal to 49 divided by 100, that will be 0.49, isn't it? I'll take 1000 trials. Okay, so among them I'll take 499 head, 5 not 1 tail. I'll take unequal because it may not happen 500, isn't it? Let me take little unequal thing. So then what will happen? 499 divided by 100. This is equal to 0.499. Look at here, this value is approaching 0.5. If you take large number of trial, if you make this number of trial to infinity, this value will go to half. Are you getting my point? This is how you need to verify. Okay, we call this one a statistical interpretation. Any probability that has only statistical interpretation, by 1 or 2 trial you can't verify that one. I hope this point is clear. But find the difference. Here you can use only one coin, you can toss again and again, but in quantum mechanical system you need to take identically prepared system. I hope you can you go through this basic probability briefly, okay, not much. Okay, now let me start with Griffith's example. I hope you have done something. Discrete probability, discrete variables. Your head and tail, those are kind of discrete variable. If you toss a dice, okay, that's a kind of discrete variable. Is that okay? In case of your Bohr atom, okay, your energies are discrete variable, isn't it? You have E1, E2, E3 like that. In case of quantum harmonic oscillator, energies are discrete variable, isn't it? In case of spin angular momentum, discrete variable, quantized, isn't it? Quantum, so ideas will come in case of quantum mechanics, isn't it? So that's why we shall go through this discrete variable, but we shall go through one very simple example that he has given. Okay, look at here, one person, again age here, number of people, age here, number of people. I have taken group of people. Okay, so now one person aged 14, age is 14, 15, 16, 22, 24, 25. Okay, one person. So can you just tell me one person aged 14, one person aged 15, 3 person aged 16, 2 people aged 22, 2 people aged 24, 5 people aged 25. Is that okay? So this is what you call some practical example. You have a group of people. How many people? 14? So total number of people, what is that one? 14, isn't it? 14 is the number of people. Is that okay? Now look at here. A number of people with age 14, okay? What is this one? That's equal to 1. Number of people with age 15, that's equal to 1. Number of people with age 16, that's equal to 3. Number of people with age 22, that's equal to 2. Number of people with age 24, that's equal to 2 again. Number of people with age 25, that's equal to 5. Now, to get total number of people, let me take this n as total number of people. That's equal to, look at here, you can make the summation over n of j, isn't it? Over all possible j. So, total number of people, you can make the summation, where j is the age here, okay? J runs from 14, 15, 16, 22, 24, 25, okay? Yeah. Now, I am not writing j runs from 14 to like that, okay? Now, so that is the total number of people, and we know that total number of people is equal to 14 in this situation. Is that okay? Now, my question is, if you select one individual at a random from this group, okay, from this 14 group of people, if you select one person randomly, okay, what is the probability that person age is 15? What is the probability that, again, this is first one, okay? So, question number 1. What is the probability that person age is 15? Randomly, so chosen, okay? So, whenever you do toss, you should make it random, okay? You should not make anything favor, okay? You should not do any politics. Is that okay, or how to say? Favor means not politics. What is that? I'm not getting word today. Manipulation, okay? Not manipulation. Yeah. Anyway, so now again you are picking a person randomly, okay? You are picking a person very randomly. So then, what is the probability that age being 15? Is that okay? That is number of event that is favorable to that one. Only one, isn't it? Divided by total number of possibility, you have 14 people. Is that okay? Similarly, probability of 24. Speak out. Speak out. 2 by 14. Am I right? So there are 2 people with age 24. Total number of so possible event that can be 14, isn't it? So like that. Now look at here. If you add all of this, probability of 14. So wait a second. Let me ask one question. What is the probability of age being 17? Quickly. 0, because there are no people with that age, isn't it? It's 0. Now look at here. Now, if you add all of these probabilities, okay, so probability of being age at 14 plus probability of getting age 15 if you pick a person randomly, probability of getting age 16, so plus probability of getting age 22 plus and so on, or let's write 2 more, okay, plus probability of 24 plus probability of 25. So what is that should be equal to? Or can you just do this one? Can you just do this one? 1 by 14 plus 1 by 14 plus 3 by 14 plus 2 by 14 plus 2 by 14 plus 5 by 14. Am I right? What is this one equal to? Quickly, if you take 14 common, that should be equal to 1. That means either you should get, again, so if you pick a person, look at here, again, his age should be any of this, am I right? If you pick one person randomly, his age should be any of this possibility, isn't it? In this definition of probability, remember, in this definition of probability, can I say like this? Probability of picking, so probability of getting the age A, that's equal to number of people with age J divided by total number of people. So shall I write like this? Now, in this definition, it's a kind of ratio kind of definition. Total probability is equal to 1. It's an inbuilt phenomenon. Is that okay? So, if I define probability like this as a ratio, number of event favorable to that one, divided by total number of possible event, definitely total probability will be equal to 1. But in quantum mechanics, we haven't defined wave function like that. Is that okay? Wave function came from a solution of Schrodinger equation, then later we interpreted. Okay, wave function has no definition of some ratio. So that's why in that case total probability need not be equal to 1. Then if you want to do any probabilistic interpretation, first you should make total probability equal to 1, then you should go for any probability interpretation. Are you getting my point? Quickly, any question? So that's why normalization needed. Here normalization is not needed. It is already normalized to 1. Is that okay? So now if I define probability like this, I can say summation over j, p of j. J should run from all possible ages, okay? That should be equal to 1. Probability of getting age j, okay? If you pick a person randomly. Is that okay? So second question is what is most probable age? Okay, you can do this one. What is most probable age? Quickly. Apply logic. 25, because there are more people, isn't it? There are more people with age 25. That's why 25 is the most probable age that you can do, isn't it? What is the most probable age? So because P of j is at maximum, am I right? P of 25, that is maximum 5 by 14. Am I right? So that is maximum among these. No other probability is more than this one, isn't it? That's the maximum one. So third one. What is median? So median is, look at here, it's a kind of middle point, okay? So suppose if I take age 23 here, okay? Let me take age 23. I call this 23 as median. Median is defined like this. So there are 7 people who aged more than 23. There are 7 people who aged less than 23. There are as many people who aged more than 23 as that of people who aged less than 23. Is that okay? We call this 23 as median. You can't take 22 or 24, okay? If you take 22, you have to count this one also. So I'll take middle of this 22 and 24. So 23, we call this one as median because there are as many people who are aged more than 24 as that of people who are aged less than 24. So can you see this one? Is that okay? If I take 23 here, so that's why median it is 23 here. Okay, it is not much important for our purpose. Okay, in case of quantum mechanics, but in any distribution we define median usually. Okay, I don't think this is quite important for us. Okay. 4. This is very important. 3, 4. This is very important. What is the average age? What is the mean age? Is that, how do you, in principle, I mean, in the simplest way, how do you take average of ages? Now look at here. You have one person with age 14. Am I right? You have one person with age 15. You have 3 person with age 16. Am I right? So then you have 2 person with age 22. Speak out. You have 2 person with age 24. You have 5 person with age 25, isn't it? Then what you do? You have added all possible ages of all people, isn't it? 16 should come 3 times, 22 should come 2 times, isn't it? Then what you do? Divide by total number of people. That is the average of age, isn't it? So that is the average of age. What is this one? Again, I don't know the value, okay? You can just count this one, okay? But this is how you do, isn't it? Okay, now look at here. I'll convert this one into most general formula, just like this, Okay, I'll convert quickly this one to most general formula. What is this one? I'll write it as summation over j. This is age j, okay? J into number of people with age j. Am I right? N of j multiplied with j. So divided by total number of people. Summation over j. Am I right? That's what you have done. I'm just converting this one into generalized formula. So this is nothing but average of ages. Okay? Average of ages. So can I write like this? Check this out. The same thing I'm writing in terms of formula so that I can apply it anywhere. Anyone? Any question? No, isn't it? I think you have done this one. I'll quickly move little faster, okay? Yes. Over? Now look at here, I am going to manipulate this one because here, okay, I know this distribution, everything, okay? I know this one, but in case of quantum mechanics, we define probability, okay? From probability, we need to find average. So that's why I'll try to convert this one in terms of probability. Look at here, I'll take this n inside. This n is constant, okay? You can take that constant inside. If you take that constant inside, what would happen is summation over j, okay? N of j divided by total number. This capital N is total number. I mean, n of j is variable. Is that okay? So into j. That's why I can write average j is equal to, look at here, what is this one? Yeah, summation over j. So j into p of j. Let me write j first, then so p of j. Okay, this one is p of j. Look at here. Okay, so j into probability of j. So this is the way of taking average if you know probability. And we are going to use this one in quantum mechanics. Clear? So what is the average of the squares of the edge? What is the average of the squares of the edge? Then what you do, you square these things, isn't it? You square these things and then you take the average. So average of squares of the edge, you can write like this. Similarly, you can write like average of squares of edge. This is the average symbol. Sometimes we write j bar. I hope you know this one. Sometimes we write j bar for average. Okay. What is the average of squares of edges? Okay. So that's equal to again j into j square into p of j. Okay. So similarly, average of any function of j, square, cube, like that, that's equal to that function of j multiplied with probability of getting edge j, take summation. Is that okay? Quickly. I hope if you read that one, then I think you don't, I mean, if you read that one day before, I think you will get less doubts also, am I right? Whatever I speak, more point will be convinced actually. That's a good idea. Now look at here. So you just write this down. Let me rub this out. I need this one, okay, in a moment. I'll take, again, he has taken two histograms here. I will take some other histogram, okay? I'll take some other histogram. I have two cities, okay? I have two cities. I have taken lakhs of people, okay? Suppose number of people in the both cities is same, okay? Let me take like that. So when I take lakhs of people, what I do is in age j, okay? In age j, I'll make very small interval, okay? I'll make very small interval. If you have lakhs or crores of number of people, okay? I'll make small interval, like so 24 to 25 age. I'm going to divide that one into many parts, and I'm going to find person who age 24 year 1 week, person who age 24 year 2 week. Like that, I'm going to divide. Okay, I can divide that one, isn't it? So then I will have some distribution. Okay, I'll take two examples. Okay, there are two cities. In one cities, suppose I'll take age 24 here. Okay, in one city your histogram is like this. Okay, so now since you have taken large number of people, your histogram almost looks continuous. Okay, like this. These are the points actually, not lines. Not lines. These are the points actually. Is that okay? Point. Because I have divided this one into small part. Okay. So can you see this one?
Yes, sir.
Yeah. So I'll take another city where again your what you call. So this is symmetric about 24. Okay. This distribution is symmetric about 24. Okay. J. I have again another distribution of ages, but what is happening here is what is happening here is, it's also symmetric about 24, but it's quite different distribution. In this city, okay, in this city, n of j, so there are considerable amount of people who are of less age, considerable amount of people who are of more age, considerable amount of people who are very aged, okay, old people, considerable amount of people who are children. 24 is the young age, let me take like that, okay. So in this city, so there are very less number of children, there are very less number of old age people. Let me take like that. Is that okay? But total number is same, okay. So total number is same. That means area under the curve is same. In that case, area under the curve is same. Let me take care of that one somehow, okay. Is that okay? Area under the curve is same. Total number of people is same. I have taken same number of total number of people in the both cities, okay. City 1, city 2. City 2. So now look at here, in both cases average j, even though total number of people same, even though distribution is different, distribution is different, isn't it? You get average 24 only, isn't it? Why? Look at here, your distribution is symmetric about 24. There are as many people who aged more than 24 as that of people who aged less than 24, isn't it? There are as many people who aged more than 24 as that of people who aged less than 24. So distribution is symmetric about age 24. In that situation, definitely average will be this one. Can you yes. Tell that one logically? Average will be 24, isn't it? You have to take what you call, when you take the average, it will come to the middle of the distribution. If it is asymmetric, it may not be exactly at the peak value, okay, if the distribution is asymmetric. You just work out from any textbook. Is that okay? Now look at here. But even though average is same, there is some difference in these two distribution. These two are not same, isn't it? So I have taken two different cities. So two different, so again, what is the difference here? Can you quickly tell me what is the difference?
The deviation.
Deviation. Spread, isn't it? Spread in the distribution is more, spread in the distribution is less. So that's why I need a measure of spread of the distribution. I need a quantity. I need a quantity which measures the spread in the distribution. Something is different here. Average, again, by just looking into average, you can't say, isn't it? You can't say about distribution, is that spread in the distribution. Now I need a quantity which measures spread in the distribution. I need a quantity which is more here, which is less here. Is that okay? So then look at here, observe this one. In this city, individual people age that deviates more from mean value, isn't it? Individual people age, so here you have considerable amount of people here, isn't it? Individual people age, okay, that deviates more from 24, mean value, isn't it? Mean deviation. Deviation from mean. Deviation of the ages from mean, that is more here, isn't it? So look at here. Again, deviation of individual people age from mean, which is less here. We call that one as mean deviation. Deviation from mean. Deviation of ages from mean, that is very less here. Let me touch this one almost to 0. That's the best idea. Okay? Is that okay? So then look at here. What I do is I am going to define delta J, mean deviation. I have taken example of ages, cities and all. Okay? Again, but I am building a what you call generalized a symbol here. Okay? So delta J, okay, mean deviation, that's equal to individual age J minus mean value. We call this one as mean deviation. We call this one as mean deviation. Now you can write it reverse also. Okay, you can write this one as average J minus J also. You can write like this. This also mean deviation. This also mean deviation. Let me pick one of them. Okay, deviation from the mean, isn't it? So this deviation from the mean, it will talk about actually spread of the distribution. But I need a constant which talks about spread of the distribution. This is a variable, isn't it? Look at here. This is a variable. For a full distribution, I need a constant actually, constant value which estimates its spread actually, which talks about its spread of the distribution. Is that okay? So that's why what I do is I will go for finding average of mean deviation. Okay. What will happen is, look at here, this is variable, this is constant. Okay. Constant averages itself. Variable average, its average. That will be average j minus average j, that's equal to 0. Are you listening?
Yes, sir.
Yeah. Average of this mean deviation is 0. Why that average of 0? Just observe carefully. Okay. Now look at here. This one is this value will have positive as well as negative. If suppose j, okay, if suppose j is greater than 24, it is positive. Average j is 24, isn't it? If this j is greater than 24, this whole thing is positive. If this j is less than 24, this whole thing is negative. There will be as many negative value as that of positive value, average of 0. Exactly the same thing happens here. And this is true in case of any distribution. It need not be symmetric. Okay. In case of any distribution, try that out. Okay. We have taken symmetric distribution. So in Griffiths also, so it is taken like that only, symmetric distribution. Take asymmetric distribution, then also average of mean deviation is 0. Okay. In case of asymmetric, again, if there is any asymmetry in the distribution, then again average will not be at the peak. Okay. It will be other than peak actually. Are you getting my point? So now you better to take that example. Yeah. Now what I do is, but I need a measure. It was a good measure. Mean deviation was a good measure. Am I right? I'll get to know how many deviation happened from the mean. But when you average this out, you will get 0. So then what I do is I'll square it. Okay. So that even though again delta j is negative, delta j square is positive. Am I right? I'll square it and then take the average. Yes. Speak out. Any question? Any question? I'll take square. If I take square, j square. Yeah, speak out. Speak out. Someone is trying to speak something. Yeah. I'll take square. When I take square, look at here, that negative values also become positive square, isn't it? Now I'll take the average. Is that okay? So that this positive deviation as well as negative deviation, positive mean deviation as well as negative mean deviation, everything will add up. Everything will count, isn't it? Again, distribution, that doesn't mean the distribution in only one side. Am I right? It's a both side distribution. So that's why now I'll take average. Delta j square. After taking square, I'll take average. That will be average j square. This is already constant. Okay. This is already constant. That will be average j square only minus 2 average j. This is constant. So whenever you take average, you can take that average. You can take that constant outside actually while taking average. So that's why this is average j. J square minus 2j square. Average j the square minus 2 average j the square. Okay. That is equal to average of j square minus average j the square. Look at here. Look at the words. Okay. Is that okay? Let me rub out this one. Now look at here. We call this one as variance actually. Variance. Square root of that one. Square root of mean deviation. I think mean square deviation is called as mean square deviation. Mean square deviation or variance. This is named as variance. Okay. Mean of square of mean deviation. If you take a root of that one, we call this one standard deviation.
Root means to division.
Root means square deviation. You can say like that. Okay. Standard deviation. Okay. Standard deviation. So now look at this one. So this is equal to root of average j square minus average j the whole square, okay? Average j square minus average j the whole square. Look at how I am speaking, okay? Average j square, average of j square, average j the whole square. We call this in a standard deviation. Now this is a measure of spread of the distribution. This is more here, this is less here. Is that okay?
Yes.
Any question quickly? Standard deviation. This is also measure, okay? This is also measure, that's a root of that one. Both are the measures, okay? Now one thing that you should take care here, okay? Look at here. You have taken square and then you have taken average, okay? And you have taken only average, then you have taken square. Again, this whole thing should be always positive. This whole thing is always positive, remember. Either you should have a spread in the distribution, you should have a spike in the distribution. I mean no spread in the distribution. If there is no spread in the distribution, this is 0 actually. Here also you have small spread, but that spread is small, okay? Spread is large. You can have some other distribution. Let me take the example where there is no spread. All people with the same age. Some example. Then there will be no spread in the distribution. Then it will be 0, okay? So that's why this cannot be negative. If it is negative, this will turn out to be imaginary. Okay, that's why this always happen. Average j square is always greater or equal to average j the whole square. Try to give some other interpretation for this one. This is asked in some exam actually. Yeah, you can say 24 is the most probable value. Again, because it is symmetric and your peak value and average value are same, okay? So again, it need not be symmetric always. Your distribution need not be symmetric always. Are you done? Again,
If we do the single measurement,
suppose
then come to get the 24.
suppose your distribution may be like this also. Then average may come somewhere here, but most probable may come here. Okay, that may happen. But here I have taken average and most probable are same. So just check this out. This is asymmetric, am I right?
Yes.
But average may come somewhere here, because you have less number of people here. Average may come somewhere here, but most probable will be like this, okay?
Sir, for symmetric curve means average value and peak are same.
Average value, most probable values are same. And for symmetric curve, you should quickly able to say what is the average value without even working out anything. Here you can't quickly say what is the average value, isn't it? Okay, but here you can quickly say, yeah, this middle point is the average value, because there are as many people who aged more than 24 as that of people aged less than 24. If you average out, it will be 24. Okay, 24 is a constant. This is also constant actually. Okay, now I'll take third example. What I am doing is, I need an army. I need an army of all persons age 24. I need an army. Suppose I have taken 1 lakh people here, 1 lakh people in other city. I'll take 1 lakh army people. All again, I'm recruiting. All should be age 24. All should be age 24. Let me take like 24 to 25. Actually, this will have some kind of thing. Okay, you just see Griffith's book. 24 to 25 like that. Okay, yeah, not exactly same birthday we can't get. Okay, I'm not saying like that, but it will have some 24 to 25. Okay, what is the spread of the distribution?
0.
0, isn't it? That means here if you take average j, that's also 24. Okay, if you take average j square, that's also 24. So that sigma, that's equal to 0. Sigma is smaller here, sigma is larger here. If you compare, okay, compare to this one, sigma is smaller here, standard deviation is small here, standard deviation is large here, standard deviation is 0 here. Now look at it, the standard deviation will talk about uncertainty. Now we shall come to that word uncertainty. Look at here. So look at here, you can write it later, okay? Just to get the idea, mathematics you can work it out later, okay? So in this condition, if you pick a person randomly, okay, so uncertainty of the ages is more, isn't it? Here you have little certainty. People ages are close to 24, am I right? You have more certainty here. If you pick a person very randomly, whose age is almost close to 24 here, isn't it? That's why you have certainty here. But here, if you pick a person randomly, whose age is varying, am I right? Varying much from 24, you have uncertainty here. That's why we call this as uncertainty also. This quantity itself is called as uncertainty. Uncertainty is a kind of word, am I right? We use uncertain like that. But this quantity itself called as uncertainty. Uncertainty is less here, uncertainty is more here, no uncertainty here. Okay? No uncertainty means certainty. Certainty means before measurement also, you can say whatever the people you choose, his age is 24.
Yes.
Certainty.
Certain.
Is that okay? Certainty. Standard deviation is 0 means, uncertainty is 0 means certainty. We call this as uncertainty also. Okay? Try to grab this idea. That's what I need. Okay? Quickly. Any question?
Sir,
Yes.
something is sir, if something is certain.
Sigma value is greater than uncertainty is maximum.
No, there is no uncertainty. What do you mean by uncertainty maximum? Uncertainty is, I am saying standard deviation is called as uncertainty. There is another name for standard deviation, that is uncertainty. Standard deviation is a constant value. There is no maximum, minimum in standard deviation. There is a constant value. These are average values, isn't it?
Sir, sir, if something is certain, then before measurement we can say it is certain.
Yeah, before measurement I can say all people aged, before measurement, whatever the person you pick, his age is 24. Can I say like this? But here,
Sir,
before measurement, you can't say.
Sir, I have an
Sir,
idea.
is our observation is not measurement. We have to do some observation to find.
Observation is picking up. Observation in this case is picking a person and asking him what is your age.
Sir, I have.
And sir, observation does not lead to measurement.
Observation is a measurement here. Okay, picking a person randomly and so checking his age is the measurement here. Is that okay? Again, I am not taking quantum system. Don't again exactly link that one to quantum system. There we need to do measurement. Okay. Is that okay? So this is a practical distribution, right?
Sir, is it like that in the CP1 and CP2, if I take the limit tends to 0, then
Which limit?
the age of 24,
This width, if you make it tends to 0, it will happen like this.
then it will be certain.
It will be certain. That's what I have done here in this one. I have taken same number of people. Okay? I'll take same number of people.
So limit width tends to 0.
Yes.
It will be certain.
Yeah. So we shall see in case of our function, our Dirac delta, a continuous function, our Dirac delta will help us to define this kind of thing. Dirac delta function. Okay, we shall see that one later. I mean, lot of mathematics are involved here. Okay, but this is what you have to grab from mathematics. Okay, yes. This is uncertainty is the another name for standard deviation. Okay, but uncertainty we use as a what you call cause kind of how to say.
Measurement.
No. This is one of the value also. This is one parameter also. That's what I am saying.
Yes.
Along with we say uncertain like that. We say that kind of word, isn't it? Along with that, the same name is corresponds to one parameter also.
Okay.
Uncertainty is less here, more here, no uncertainty here. Okay? Yeah. Individual people picked here, their ages are close to 24. Is that okay? Less uncertainty, like that we say. Okay? Yeah. Think over it. Okay? Think over it and do some problems from Griffiths so that you will get much more idea. Now I got many formulas here. Okay? So probability of J, that's equal to n of j divided by n, okay. Then I got average of j, that's equal to summation over, oh, no, this is next part is normalization, am I right? This is an inbuilt phenomena because you are defining it as a ratio, that's equal to 1. So then next one is average j is equal to summation over j into p of j, okay. So summation, again summation over j square, that's equal to summation over j square p of j, or any function of j, you can write like this, isn't it? I have written that one. So similarly, let me write one more, function of j okay. So standard deviation, that's equal to root of average j square minus average j the whole square. These words will remain in your mind, again that's what I practiced, okay. Average j square minus average j the whole square, okay. Continuous variable. Whatever Born interpretation we have done yesterday, okay, mod psi square, yes.
YouTube video is for
Okay, wait. Got it. Thank you.
Sir,
Yes, one second. Let me check. I think I am back. Check that out.
yes.
Yes.
Sir, Chandana
Hmm.
asked one question. What about the standard deviation in that asymmetric distribution?
No, it will be. You have to count that one. You have to take one example. There will be standard deviation if it is asymmetric also. Okay. Here also I didn't count it. Okay, I have taken an example. You take some particular example, particular histogram, then you need to work out that one. Okay. Yeah, this kind of question you can search. Okay, you can search about that question. He has taken symmetric. You take some asymmetric and you can work out. Okay. But I need some idea, mathematical idea here. Okay. I need some mathematical idea from that one. Now look at here. You have a situation. You take entire country. Okay. So entire India. There are many people, isn't it? If you talk about probability of getting some age, then you should minimize that interval, isn't it? You should minimize that interval. Are you getting my point? If you take entire country, we have 130 crore people, 130 to 140 crore people, isn't it? Then while talking about probability, you better to decrease, minimize the what you call age. Now here, whatever I have taken 24. Means I have taken age from, again I have taken people from 24 to 25 actually. Just check out Griffiths properly, okay. So age 24 means 24 to 25. Age 25 means 25 to 26. Age 24 means less than 25, more than 24. Okay. Age 25 means 25 to 26. That's what I have taken over there. I mean, I have taken one full year as a range. Okay. 24 age to 25 age. I have taken that range as one age over there. Now I am going to decrease that one to an hour, isn't it?
Yes.
Okay. 24 year 1 hour. 24 year 2 hour. So can I make it like this? Because not even 1 hour. I think again how many child born
In India.
uh,
In 1 hour.
in 1 hour more, isn't it?
Around 300.
Around 300.
Maybe.
Anyone? Somebody is searching then in Google, isn't it?
I heard about that.
No, anyway, now that is too huge, isn't it? We can even make it as half an hour or we can make it as 5 minutes. Like that. Now look at here, but even though you make that what you call length of that one is small, okay. So in your distribution, so again in case of j, I am going to what you call divide this one. Earlier I have divided 24, 25 like this, okay. So but now I'm going to divide it into small part. even though you divide into small part, okay. So there again, if you take what is the probability of getting age 24 year, 24 here, 1 week, okay, 1 week, 2 hour, 5 minute, 6 second. If you say like this, then there may not be any what you call people with this age, isn't it? Are you talking about?
Maybe yes.
A continuous variable means it should vary continuously. Age should vary continuously. If you take one of the age x, suppose, okay, then that age should be, again, that's a very sharp value, isn't it? From 0 to 1 in case of your x-axis, from 0 to 1 you have infinitely many values, isn't it?
Yes.
6 second, you have to go for millisecond also. 6 second, so 2 millisecond, isn't it? After 6 second, 2 millisecond happen. After 5 minutes, 6 more second happen. After 2 hours, 5 more minute happen. Again, in case of continuous values, if you choose one particular value, it has a decimals, am I right? It has a decimal. You can talk about 0.6666 or something, isn't it? You can talk about some decimals. Then look at here, again, there may be no people with this age, isn't it? Are you getting it? So that's why what we do is we take some length, small length. Earlier also we have taken that length, but that length was big. We take a small length, just like 5 minute length. 5 minute length is too small actually, compared to entire our age of 70 years, 70 to 80 years. 5 minute is very, very small. Is that okay? So now we take some length here, and one thing you need to observe. So again, you can't define this probability. I hope you got the idea here. Okay, you can't define probability of very specific age. Then that age will become fraction. Okay, that age value become fraction. You can't define that one at all. There may be no people with that age. So that's why what we do is we are going to define probability of getting age with some range. 24 year 5 minute. I'll have some range. Okay, I'll have some range. And now length of ages. I'll take one length of ages. 24 year to 24 year 5 minute. 5 minute is my length of the interval. Okay. Now this is proportional to that length actually. This probability is proportional to that length. Whatever the probability you define, that is proportional to that length of the interval actually. Is that okay? So then whatever the probability you are defining from x to x plus dx, okay, that probability is proportional to dx actually. In case of any continuous distribution, probability of getting that value, that value is continuous, okay. Probability of getting that value from x to x plus dx, that is proportional to length of the interval. Here if you take probability of, so probability of getting 24 year to 24 year 5 minute, okay. This is proportional to 5 minute, okay. If you make it 10 minute, it will be also doubled actually. Okay, this is the interval. 5 minute is the interval, okay. If you double the interval, this probability will also be doubled. That is the basic idea. So now this here we write one thing. This is not a constant. This is not a constant. We call this as density. We call this as rho of x. This need not be constant. Don't say it is a proportionality constant. This probability not only depends on interval, it depends on different age. Am I right? You can have so density so which is different for different x value. Are you getting my point? So density again that probability, we call this as probability density. Now if this total is probability, we call this as probability density. Now that probability density, it is different. It may be different at different ages. Am I right?
So
Now what I am saying is this probability, it is proportional to interval. This probability proportional to probability density. We define one more quantity.
So we are saying that 24 years to 24, not 5 minutes, 10 minutes.
Suppose look at here, probability of 24 year to 24 year 5 minute. Okay, this is twice of this one. If you have this value, suppose x, this will be 2x. That's what I'm saying. That's why it depends on that interval. Sorry. So 24 year 5 minute, 24 year 10 minute. Okay. If you double the interval, the value will also be doubled. That is the idea.
Density will be
That's why it depends on that interval.
Yes.
Along with that, it depends on other factors also. Am I right?
Yes.
That is this one, probability density. This is how we define in case of continuous distribution.
So you are saying that one.
Sir,
Yes.
if we increase the length, there's a distribution. There's a peak of the distribution to force to down this one.
No. I'm not taking any distribution at all. I'm not taking any example, particular example. I'm defining in general. This probability should be proportional to interval length. Along with that, this probability depends on this x also. This may vary. That density may vary. Okay, probability per unit length, that may vary from point to point. Don't take any particular example. This is most general thing that I am trying to convince. One thing you should be convinced: if you increase the interval, then definitely that will increase as like that. Okay. If you double the
Earlier case, we are not saying the density of anything.
no, earlier case, again we made this one very big, one thing.
Yes.
Okay, and other one is we don't need any densities. That histogram is different. Here we are tending to continuous thing. This is also not even continuous. Am I right? It's also not continuous. Again, so what will happen is you can't talk about probability at some x naught value. You can't talk about that one. Just like probability of saying 24 year 1 week 2 over 5 minutes 6 seconds 2 milliseconds. Some one particular x naught value. You can't talk about this one at all. You can only talk about probability in some interval. Are you getting my point? Just read Griffiths. That's the best example that he gave.
Yes, sir.
You can't talk about probability of getting one particular sharp value in case of continuous distribution. You can only talk about probability within some range. And this dx is infinitely small, mathematically, technically. Mathematically, this dx is very, very small in case of any continuous distribution, but it has some width actually, not 0. Here x naught to x naught plus 0, isn't it? But that cannot be defined in case of continuous distribution. So this is the basic idea.
Sir,
Yes.
Sir, if we talking about the width, then the probability should be the area under the.
No, look at here. Since dx is very small, this will lead to a kind. You should wait for this one. Okay. So this width will be a kind of one line actually. Since this is very small, if you integrate, you will get area under the curve. So this is area only. This is area only. Height into some width. This is area only. Okay. But this is very sharp line, one ribbon actually. It's a kind of ribbon. You better to see my integration concept, whatever I have explained. In the basic math.
But sir, in this case, if we increase the width, then.
Yeah, then definitely probability will increase. But mathematically, wait. But mathematically, this dx is have same what you call width actually. Mathematically, it is infinitely small. This dx you can't vary this dx range actually. Very, very small.
Like infinitesimal number.
Infinitesimal number.
Like this is called like when delta x tends to 0.
Like that. Delta x tends to 0. We define that one as dx. Am I right?
We can say this.
In case of calculus, similar. That calculus dx only. I am writing.
Yes.
Okay. But this parameter should be there. You can only talk about some, even though it is very small, you should talk about some range. Okay. Even though it is very small, you should talk about some range here. Suppose 2 over 5 minute to 6 minute. Should at least have 1 minute range over there
Yes.
to talk about age. Is that okay? That range is this one. That should be very infinitely small. Okay. Mathematically. Now look at here, we define it like this. So now this is probability density. This is the total is probability. Okay. Probability is always dimensionless quantity. It's a ratio kind of thing. Look at here. Probability should be dimensionless quantity. Then what is the dimension of this one? Per length. Per length into length, dimensionless. Okay? Just see that one. Again, I am not writing in a sentence. Okay? Probability of getting the value x to x plus dx. Okay? So now, if you need probability from a to, again, now you can draw this rho of x. Rho of x is a continuous function. Am I right? Now you can draw this rho of x. Rho of x. It may be some continuous function, okay, like this. Now, if you want probability from a to b, now again, in this situation, look at here. What is the normalization? If you take minus infinity to plus infinity, rho of x dx. First, you have to ensure this one. Total probability is equal to 1. This is a kind of total probability now, isn't it? Just like this one. In case of summation, okay. So then probability from a to b. So that's equal to, you should integrate a to b. After ensuring this one, then only this is meaningful, okay. Yeah. Again, but once you, if you define this one, if you define this probability as a ratio, let me take some example, okay. Then you don't have to check this one. This will automatically happen. But in quantum mechanics, it will not automatically happen. We have to enforce that condition, okay. A to b. Rho of x dx. Once you have that one, look at here, I'll compare and then write. I'll compare and then write average value. What is average x value? That's equal to, now it will become integral. In case of probability, I'll put this one, okay, rho of x dx. I'll put x, summation over all possible j, integration over all possible of value of x. Okay, summation over all possible value of j, normalization, isn't it? So integral over all possible value of x. This total is the probability. This total is the probability. So average x square. Integral minus infinity plus infinity x square into rho of x dx. Write this rho of x dx together. You can feel that is a probability. So sigma x square minus average x the whole square, okay. So any average of function of x, integral minus infinity to plus infinity, integral over all possibility. Earlier it was summation over all possibility. That function into probability, rho of x dx. Is that okay? Quickly.
So what we can think of probability density in
No, probability density is a continuous function. It will talk about where the probability is more, where the probability is less. Now look at here. So at A here, yeah, it is most probable. Okay. Whenever any continuous variable comes, we talk about density. Am I right? This density doesn't mean per unit volume. We are in a one dimension. Okay. This is probability per length actually. Per length is also called as density. Probability density, most general word. Always don't think that density means per unit volume. Is that okay? This probability density will talk about where the probability is more, where the probability is less. Isn't it? Where it is most probable, where it is less probable, it will talk about that. That's the function. Is that okay? Now, yes, yeah. Now, suppose if you are not defining this probability as this kind of ratio, then you have to enforce this condition. That's what we do in quantum mechanics. Okay, that's what we do in one more example also.